Okay, everyone, here we go with the screencast of graphing quadratic functions, lesson 8.3. We're going to try to go through this quickly because the videos, if they're too long, they won't upload. So I'm going to try to get this video done in under 5 minutes, and if necessary, I will upload more videos to get through what we need to get through today. Okay, so the do now, find the axis of symmetry, find the vertex. This is a review of last lesson, lesson 8.2, finding the axis of symmetry and the vertex. You need to use the equation negative b divided by 2a, and that will give you the x coordinate of the vertex. So this is a, this is b, this is c. So negative of b would be negative 4 divided by 2 times a. A is 1 in this example, so it's negative 4 over 2, which is negative 2. Okay? Now that's just the x coordinate of the vertex. You also need to find the y coordinate. So you would plug the negative 2 back in for x. So you get y equals negative 2 squared plus 4 times negative 2 plus 5. You would solve that. You'd get 4 minus 8 plus 5. You would get 1. You do the same thing to find the axis of symmetry. You need to find the vertex in number 1. So the vertex would be negative b over 2a. B in this example is 0 because there's no middle term. So the b is missing, which makes it 0. And 0 divided by anything is just going to be 0. So that's the x coordinate of the vertex. The axis of symmetry is that number. X equals 0. That is your axis of symmetry. AOS, abbreviated. Okay? Our vertex is right there for number 2. Number 3, to find the y-intercept of a function, you set x equal to 0. That's a lesson from many months ago. Finding x and y-intercepts. To find the y-intercept, you plug in 0 for x. To find the x-intercept, you plug in 0 for y. So basically, we're just going to plug in 0 where you see an x. That'll be 0, and you're left with the number at the very end, which is negative 8. This number, it always winds up being the y-intercept. That number right there. Okay, now we're going to use that information to do the first example here, graphing quadratic functions. Here are all the steps. There's 2 methods to this lesson. We're going to do only the first method today. Here are all the steps. The key to realize is this right here, that a parabola is symmetric. We're going to use that fact in order to plot points. So, first 2 steps, find the axis of symmetry and find the vertex, which we're going to do again. The same thing that we did in the do now. There's a, there's b, there's c. So the vertex is negative b divided by 2a, which is the negative of negative 6, which is really just 6. So you get 6 over 6, which is 1. So our x coordinate of our vertex is 1. To get the y coordinate, you plug it in, and you would get 3 times 1 squared minus 6 times 1 plus 1, which will be 3 minus 6 plus 1, which would be negative 2. So that's our vertex, 1 comma negative 2. We're going to plot that. So our axis of symmetry is x equals 1. That is going to be a dashed line through the vertex. That's your axis of symmetry. It's always going to go through the vertex of the parabola because it's the line that splits the parabola in half, and the vertex is the origin point of the whole parabola. Find the y-intercept. Well, the y-intercept is always just this number at the end. 1. So 0, 1 is our y-intercept. Right there. Now here's the good thing about parabolas. They're symmetric, which means this point right here, the y-intercept that we just plotted, we could reflect over there. And that will give us the shape, the U shape of our parabola right there. So what I want you to do, we reflected that point over. What I also want you to do is get a little table going of x and y values. We're going to put our vertex in the middle of the table. And then you're going to go backwards 2 units and forwards 2 units. So you're going to plug in all those x values. Now we already got 2 of them. We got 0, 1 and we know the point that we reflected is 2, 1. So now we just have to figure out the other 2 points so we could draw the rest of our parabola. So plug in either a -1 or a +3 into your equation. I'm going to plug in a +3. Um, 3 times 3 squared minus 6 times 3 plus 1. That's going to come out to 27 minus 18 plus 1, which is 10. So 3, 10 is going to be all the way up here. And we know since it's symmetric, we're going to reflect it over there. And here is our parabola, nice and symmetric, going upwards. Okay. So that's the gist of the lesson. I would like you to try this checkpoint problem, and also for homework, all the way down at the bottom. I already posted this in Google. Slide number 12, numbers 1 and 2. All right. Good luck, everyone.